guys, so I'm Stephen D, and today I'm going to talk about quadratic equation. First, what is a quadratic equation? It has the standard form of ax squared plus bx plus c is equal to 0. It is also a second degree equation where a, b, and c are real numbers and a is not equal to 0. So there are two classifications of quadratic equations. When b is not equal to 0, it's called a complete quadratic equation. And when b is equal to 0, it is called incomplete or pure quadratic equation. Here's an example of a complete quadratic equation. X squared plus 4x plus 4 is equal to 0. As you can see, b is not equal to 0 because our b is 4. And here is an example of an incomplete quadratic equation. X squared minus 4 is equal to 0. And as you can see, b is equal to 0 since we don't have a b. Here is an example of the quadratic equation in a standard form. Here is x squared plus 4x plus 4 is equal to 0. Every quadratic equation have two roots. Here's an example. 5 times the quantity of x minus 2 squared is equals to 20. Here's how you solve it. So from that we got 5x squared minus 20x plus 20 is equals to 20. 5 times the quantity of x minus 2 squared is equals to 20. We divide by 5. 2 squared is equals to 20 over 5. X minus 2 squared is equals to 4, since 5 divided by 20 divided by 5 is 4. Next, we square root that. That's why we got x minus 2 is equals to positive negative 2. A transpose, where x minus 2 is equals to negative 2. And when x minus 2 is equals to positive 2. So if it's negative 2, we transpose our negative 2 in the x, we get 0. So it's negative 2 plus 2 is equals to 0. And then x minus 2 is equals to positive 2. Transpose negative 2, that's why we got 2 plus 2, same signs, copy the sign, we add 2 plus 2 again. So the roots are 0 and 4. How do we find the roots of a quadratic equation? So we can factor or get our roots with the following. So we can use extracting square roots, or we can use the factoring methods, which are the perfect square trinomial, the quadratic trinomial, and the zero factor property, or we can use completing the square or the quadratic formula. So how do we do extracting square roots? If b is equal to 0, we can use the square root property for easier computation. So example here, x squared minus 25 is equals to 0. First we transpose negative 25, so from negative from positive, so we get x squared is equals to 25. Then we square root, we get the square root of both terms here. That's why x is equals to positive negative 5. So our roots are positive 5 and negative 5. So here is the factoring perfect square trinomial. So our example is x squared plus 2x plus 1. So one of the techniques is that it is a perfect square if it satisfies the condition b squared is equals to 4ac. So in our example, a is equals to 1, b is equals to 2, and c is equals to 1. So we substitute those values into our condition b squared is equals to 4ac. So our b is 2, so 2 squared equals 2. Our a Before that, we need to multiply it with 4, and then our a, which is 1, and c is 1. So 2 squared, 2 times 2, we get 4, and 4 times 1 times 1 is still 4. So 4 is equal to 4. So it satisfies our condition. Factoring perfect square trinomial, you can easily factor it by getting the factors and extracting the square root. So a hint, find the square of the first and third term, then multiply the answers and multiply again by 2. You will get the second term. Knowing you have a perfect square trinomial, you can easily get the factors by getting the squares of the first and last terms. So to do this, you have an example, x squared plus 2x plus 1 is equal to 0. Factor this out, square the first, square the second, that's why we get x plus 1 squared is equal to 0. And after that, we square root both. So the square root of x plus 1 squared is equal to positive negative square root of 0. That's why we got x plus 1 is equal to positive negative 0. So we just transpose our 1. That's why we get x is equal to negative 1. So the roots here are the same, or a double root. That's why our x is equals to negative 1. How about in a quadratic trinomial? If the equation is not a perfect square trinomial, you can use the quadratic trinomial or QT. Example here, we got x squared minus 2x minus 15 is equals to 0. So to do this, get the factors which will give the value of AC when multiplied and the value of b when added. So here you can see our x factor. Our example again is x squared minus 2x minus 15. So on the top of our x, it is the multiplied value of a and c, which is negative 15. And then on the bottom is our b, which is negative 2. Again, we are finding that two factors that when we multiply, we'll get negative 15, and when we add, we'll get negative 2. So the easy way to find it is using the ladder method. So as you can see, we have 15 and then 3. 3 divided by 15, we get 5, and then divided by 5 is 1. As you can see, on the side, we get 3 and 5. So let's see if it satisfies our condition. 5 times 3 will give us 15, but to make it into negative 2, we can make one positive and the other one negative, right? If we have two different signs based on the addition property, two different signs, we subtract and then copy the sign of the bigger number. That's why we got negative 5 and positive 3. 5 times 3 will give us 15, and since they're different signs, it's going to be negative. And then negative 5 plus 3 will give us negative 2. Why? Since they have different signs, we subtract them. So 5 minus 3 will give us 2. And since 5 is the bigger number, we copy that sign. That's why we got negative 2. So make sure that the signs are correct so that our equation is also correct. So x squared minus 2x minus 15 again. Our factors will be x plus 3 times quantity of x minus 5 is equals to 0. First, we need to use zero factor properties. So x plus 3 is equal to 0 and x minus 5 is equal to 0. So transpose positive 3, transpose negative 5. That's why we got x is equals to negative 3 and x is equals to 5. So our roots are negative 3 and 5. So extracting square roots. If b is equal to 0, we can use the square root property for easier computation. For example, x squared minus 25 is equals to 0. So in zero factor property, the product of AB is equal to 0. If A is equal to 0 or B is equal to 0 or both, A and B are equal to 0. Then factor the equation and equate it to 0 to get the roots easily. So here's an example of the zero factor property. X squared minus 7x plus 12 is equal to 0. So first we get the factors using QT. Again, we talked about that, the x factor, and then two factors multiply will give us 12, and we add will give us -7. So again, use the ladder method, and our factors are -3 and -4. Since our factors are x minus 3 and x minus 4, now we can use zero factor property. So x minus 3 is equal to 0 and x minus 4 is equal to 0. So we transpose -3, transpose -4, that's how we get x is equal to 3 and x is equal to 4. Roots are 3 and 4. Now in completing the square, the left side is not factorable. You can use completing the square. The goal is to make a perfect square trinomial, so you can get the roots easily by extracting the square roots. If c is equal to 0, you may use completing the square to get the roots. So our example is x squared plus 4x is equal to 0. So use the formula 1/2 b squared and add the answer to both sides of the equation. So again, 1/2 b squared, our b is 4, so we substitute 4, 1/2 b squared, so 1/2 times 4 squared, so 1/2 times 4, you can just put 4 on 1 right there, so it will be 4 over 2, and 4 divided by 2 will be 2. Then 2 squared is 4, that's why it's equals to 4. Then completing the square, x squared plus 4x plus the one we just found, 4, is equals to 0 plus 4. You add to both sides. So now we can use extracting. So we extract x squared and root of 4, that's why we get x plus 2 squared is equals to 4. 0 plus 4, we get 4 still. And then we get the square roots of both. That's why we got x plus 2 is equals to positive -2. Then we'll have an equation where x is equals to 2 plus 2, and an equation where x is equals to 2 minus 2. So 2 plus 2 will get 4, and then 2 minus 2 is 0. So our roots are 4 and 0. Another example, we got x squared plus 6x plus 8 is equals to 0. So again, use 1/2 b squared, so our b is 6. So 6 divided by 2, we get 3 squared. So 3 times 3, we get 9. So we add that to both equations. So we get x squared plus 6x plus 9 is equals to -8, since we transpose that, plus 9. So again, we can extract the square roots from there. So x, square root of x squared x, and then 9 will get 3. And then we subtract -8 plus 9, since they're different signs, you subtract them, then get the sign with a bigger number, that's why we got 1. And then we get the square roots of that one, that's why we will get x plus 3 is equals to positive and -1. So we're gonna have an equation where x is equals to 3 plus 1, and another one where x is equals to 3 minus 1. So x is equals to 4 and x is equals to 2. So our roots are 2 and 4. Now the quadratic formula. The quadratic formula can be used to get the roots as well. If b is an odd number, you can decide to use the quadratic formula so that you will not get a fraction. Complete the square and solve the roots easily. So the quadratic formula is x is equals to -b plus minus square root of b squared minus 4ac over 2a. So here's our example. X squared plus 3x plus 2 is equal to 0. So first we need to get a, b, and c. So our a is equals to 1, b is equals to 3, and c is equals to 2. So again, our formula, plus minus square root of b squared minus 4ac over 2a. So we substitute our values. So negative 3, since that's our b, negative b, so negative 3. Plus minus square root of 3 squared minus 4 times 1 times 2, which is our c, over 2 times 1. So if we solve that, we'll get negative 3 plus minus square root of 9 minus 8 over 2. So we'll get negative 3 plus minus square root of 1 over 2. So the square root of 1 is 1, so we get negative 3 plus minus 1 over 2. So we're gonna have an equation where it's positive 1 and an equation where it's negative 1. So if we solve that, we'll get x is equals to negative 2 over 2, another one where it's negative 4 over 2. So our factors are gonna be x is equals to negative 1 and x is equals to negative 2. So our roots are negative 2 and negative 1. Thank you for watching. I hope you enjoyed this video and watch out for part 2 of Quadratic Equations. Bye!